Hey, how it's going, guys? In this video, we are going to look at memory management for agentic AI system. One of the most important component of building AI agents or agentic AI, in enterprise or even in production, even at startups, or if you are doing individually, right? We're building, AI agents, multiple agentic AI systems, so on and so forth. The most important thing is memory management. Memory is the most complex topic also within the agent ecosystem. It's not that easy to implement, and there are different types of optimization strategies that can be used to improve the performance of AI agent system. That's what we're going to look at in this video. Look at the memory and how we can design, the memory management part of it, and how to optimize those memory when you are building AI agents or agentic AI is being used interchangeably. Agentic AI has more autonomy, one of the characteristics, but quite similar. So if you look at here on my screen, I have this, and we're going to make it open source, by the way. This will be available to you. So you can use this entire playground, all the code and everything. So if you look at here, it says AI agent, memory design and optimization playground, interactive testing environment for multiple memory optimization techniques. If you look at here, it says available memory strategies. It starts from sequential memory, goes up to OS like memory, operating system memory, more like RAM and disk simulation, my favorite, by the way. So starting from sequential, we're going to look at sliding window memory, we're going to look at summarization memory, we're going to look at retrieval memory, we're going to look at memory enhanced, augmented or enhanced memory as well, hierarchical memory, graph memory, compression memory, and then in last OS like memory. So we're going to talk about all of these things here, how to use it, when to use it. I have created this entire Notion page for you, so you can also go through it with the documentation, code snippets, so on and so forth. So this is the only video or the code base or the documentation or the project, whatever you call it. This is the only resource that you need to master, memory part of building AI agents or agentic AI. So we're going to go through all of this, and we have something called single tester, batch comparison. You can compare multiple memories, multiple memory strategies that you can compare over here that you see. And then we have performance dashboard. Performance dashboard data is not yet there because I haven't tested it yet. I'll show you in a little bit. Single tester, let's say we're going to talk about sequential memory, right? And I say initialize agent. The moment I hit initialize agent, you can see a chat interface opens over here. And let me show you what I mean by memory, right? Most of you probably are not aware of memory, right? And you want to learn about it. So let me show you an example here. I'm going to say, hi, uh, my name is Sonu. And I'm going to send this. The moment I send it, it goes to a model. We are using OpenAI models. You use any model, doesn't matter here. The the thing that we're talking here is about memory. Okay, so if you look at here, it says, hi, my name is Sonu, and it gives me an answer. It says, hi Sonu, it's nice to meet you. How can I assist you today? It also gives you the token count. So that is very important. So we're going to look at the latency, we're going to look at the token count, we're going to look at the accuracy, and of course, collectively we're going to look at the performance of it, right? That's the agenda of it. So here you can see, hi, my name is Sonu, and I just asked this question here, and let me just ask other thing. I am exploring quantum AI, and I just do send now. Okay, you can see that sounds fascinating. Sonu, quantum AI is an exciting field. So first I ask a question. My name is Sonu, and then I ask, I'm exploring quantum AI. Now I'm going to ask one more thing. What did I ask you first? And the moment I hit enter, it's going to answer me that, Sonu or something. Okay, you can see over here, it says, you first asked me to introduce myself and mention that your name is Sonu. So this is what memory is. Memory means for agents. Human memory is really different, guys. We have a long-term memory. We have a different way our memory works. The way human brain functions, it's not exactly how we do. Right now, it's all context and database that you see when we talk about memory in AI systems. It's all database, to be honest. Even if you're building it on production grade, it's still databases, okay, to be honest. So if you look at here, it says, what did I ask you first? And it answers me that you first asked me. But look at the number of tokens that it has consumed and time. 1.8 seconds, 109 tokens. When you are building production grade, right, agentic systems where you have n number of users and it's conversational in fashion, imagine how much memory, compute it's going to utilize. The memory part, it's going to utilize a lot of compute. Latency will become an issue. Token cost will become an issue. Why I'm saying this, because from a recent study that I was reading from Gartner said that 40% of AI projects will be cancelled. The agentic AI projects will be cancelled by year 2027, I believe, or six, whatever. So what does that mean actually? Because we are not having a good governance layer by 2027 here. That is C. So memory also becomes part of that governance layer. So you have data ops, where you look at the data layer. You have your LLM ops. The LLM ops comes up because we are talking about LLM based agents. Similarly, we also have to have memory ops, to be honest, right? Now we have to look at the memory layer of it. So that is also very important. Now this was the sequential memory, and let me show you. Here we have a memory statistics that you see: memory size, six messages, conversational turns, and in the detailed statistics, you find out all those details. Strategy type, the sequential memory, total messages 6, total turns 3, total content tokens, and prompt tokens. So look at that, right? It also gives you the advantages and disadvantages. Perfect recall, because recall is really going to be perfect because it's sequential in order, one after the other. So previous context goes into the memory of or the prompt, when we hit the LLM. But the problem is linear token growth. Linear token growth is a problem here because the token consumption goes high. So it's directly proportional to your API cost, right? The cost of the LLM. So that's what it is, not scalable, by the way. So this is the one aspect. Now the thing is, I want to show you this code will be with you. Don't worry about it. You can see I have created this memory strategies folder here, and all of these are, let me just show you sequential memory because it's important to show you. Now, this is the sequential memory class that we have over here. If you look at this sequential memory, it has an init function, and then we have an add message function that takes your user input and takes your AI response. That's what it takes, and append into a list, basically. That's what it does. And then it also counts the token and get context. Very simple memory here that you see, get memory stats. The sequential is the most easy one. So similarly, like sequential, I have created different modular classes. You can see these are all modular, these are all class. So we can use this in any one of our application also with any framework that we are using, that if you want to use, right? So let me just go back and show you this. This is one thing. Now to explain this further, right, I have created this agent memory design and optimization that you see, because this is really important for you to go through and understand. So the memory challenges, the first thing I told you, why we need memory, right? So we need memory because of LLMs are, statelessness. They don't have a state, right? You need, because they are like prompt based actions that they do. You ask a question, it returns an answer. And most AI agents are now LLM based agents. The other challenges are exponential token cost, right? It's a conversational history grows up. Let's say on daily basis, if I'm having 2 hours of conversation, right, it really goes high. And if you have seen recently, Sam Altman has said, don't say hi, hello, or please, or thank you, or something to chat GPT, because it costs a lot of money to them, right? So don't do that actually. Then loss of context is also a very big challenge in the conversational terms. Sometimes there is a tendency of LLMs misses or lost in middle. There is something called lost in middle attack that you should read about it. It's a Stanford paper, Lost in Middle. You read about not man in the middle, excuse me. It's Lost in the Middle LLM. Yes, Lost in the Middle. How language models use long context, basically. So this is something that you should also read. That will expand your understanding of the topic. That why do we need such things, right? So going back here, so you can see loss of context, poor user experience due to repetitive information gathering. If you're asking same thing again and again, right? So we should not do that actually, right here. So that is something also there. Now then we have inefficient resource utilization in production systems, because when you work in production, it's not that straightforward that we do like in POCs, right? So memory optimization matters, right? Without memory, you can see I have this code snippet. Don't worry, I'll give you this Notion page as well, like this Notion template, whatever we call it. Okay, here I have explained everything. Just now we saw sequential memory. You can see perfect recall, simple implementations. The next is sliding window memory. Now sliding window is like it's a fixed size memory windows. Like let's say you have 3 4 5 as n number of your window. It only look at your most recent n conversation. N can be something that you can set. So for example, let's say if I select here sliding window memory, and if I select window size as 4, it will look at the previous 4 context or whatever conversations that I have over there. So that is on the sliding window memory that you see, right? It controls the memory consumption, but it may lose important information because when the conversation goes like big, right, lengthy. So that is pretty straightforward. One of my favorite in this is, of course, summarization and retrieval. I like retrieval a lot, right? Because retrieval helps me retrieve some information that only I need in that memory. Let's go through the retrieval. You can go through summarization by yourself. Let me come back here and go to retrieval memory. Now in the retrieval memory, you can see retrieval count k equals to 2. It's very similar, right? When you build RAG systems, you know the retrieval part of it, where you use embedding model, right, to do that. Let me show you how I have been doing it. Let's go to retrieval here, right? Retrieval memory. Now, if you look at the retrieval memory class, what we are doing here, we have a class that uses base memory strategy. Now, base memory strategy is nothing but this one, base memory strategy. It's pretty simple thing, so I'm not covering it. Look at the retrieval. Now, if you look at the retrieval here, we have by default k equals to 2 and have an embedding dimension of 1536 over here. And we are using text embedding is small from OpenAI. You can use any other embedding model. And we are using, it's based on Euclidean distance, the way we have implemented this memory for AI agents, the retrieval one. It uses index flat L2. Of course, that uses Euclidean distance for search, the search that we do in the retrieval, right? It's all distance based search that we use. And you can see it has, if you look at it, I also have commented it so you can understand better. List to store original text content of each document. Now, this list basically store your original text content for each document that has been kind of vectorized or whatever. And then initialize fast. We are using fast CPU for this purpose. You can use any other vector store or a vector database depending on what kind of services you have handy. And then if you keep going down, right, you can find it out. It's pretty much straightforward. Generate the embedding, takes the document. Docs are nothing but the chunks that we do. The chunks on, a recursive character text splitter or whatever you use to chunk it. Paragraph-based chunks, character-based chunks, word-based chunks, sentence-based chunks, so on and so forth, right? So this is what we do here, and then we create we vectorize it and then store that you see, right? And add vector to fast index, making it searchable. This is what we're not persisting it right now. It's on the runtime. So it's like once your session is over, this also gets disappeared actually. And this gets the content. Find k most relevant document from memory based on semantic similarity to query, right? This is what it is. And we're going to talk about that in a little bit, right? Let's go through that. And it finds out, you can see convert user query to embedding vector, convert to format required by fast, perform search, use return indices, and then you just in the memory here. So let's try it out, right? This is very interesting. So let's try okay, let me initialize agent. The moment you see I initialize agent, you can see it says retrieval memory agent initialized. And here I'm going to ask like, I'm going to ask like, I'm planning to go to UK. This is my one question that I'm just saying. Go to the United Kingdom should have been better, right? Grammatically. It says that sounds exciting. What specific information or assistance are you looking for regarding your trip to the UK? Are you interested in travel tips, places to visit, accommodations, or anything else, right? That's what it replied to me. Now I'm gonna say, you know, uh, I'm talking something else now. For my memory project, I used Streamlit as the web interface. That's what I'm going to say here. I'm just now asking something not related to that trip because I want to, make some, how should I say it? I just want to diversify that because I want to use the retrieval here, right, later on. So if you look at this, it says, great choice. Streamlit is a fantastic tool for building web applications. I agree with this, right? And something, right? Let's go and ask the next question here. I want to visit Manchester, rather I'll just go very specific. I want to visit Old Trafford at Manchester to watch United play, and something like this. And I just ask, I'm a huge Man United fan. You can see that in back, right? It says that sounds like a fantastic experience. Old Trafford is an iconic stadium. Are you looking for information on purchasing? Blah blah blah. And now I'm again gonna divert. So for the backend API, I used FastAPI. That's what I used. And after this, I'm just gonna ask one more, and then I think we are good actually. Okay, now you can see we have a lot of conversation, right? 8 documents, 8 vectors. It's happening on the fly. Okay, now I'm gonna ask what city I'm going to, you know, travel. Or let me ask what city I'm gonna travel actually. And I'm asking this question, what city I'm going to travel, right? And you can see the token that it used. That's what I want to show. Okay, you can see it says you haven't mentioned which specific city in the UK you plan to travel. Do you have a particular city? That's a problem of the retrieval. But if you look at that part here, it says 86 tokens. So it took less tokens, by the way. If you compare that with the sequential or sliding window or any other previous methods that we were talking about, maybe the retrieval didn't work out because it would have figured it out from here when I said that I want to travel to Manchester because Manchester is a city in the United Kingdom. But that is completely fine. That's not the agenda of this video, that if the embedding models are working fine or not. But here, if you look at the embedding dimensions, number of document, vectors, so on and so forth. So the number of token that it takes in the retrieval memory that you see is it uses vector embeddings and similarity search, and it uses it's really less. It takes faster response time and also takes less tokens. So the in the production, and then you have to make sure that you are using a really high quality embedding model and a vector database, to amplify this retrieval memory and make sure it gets it right. It's faster also. Like for example, if you see for the backend API, I used fast API. For this, it took like 1.49 seconds just on relying on LLM because you're passing a lot of previous context also, right? In that, if you are not using retrieval, by the way, I'm saying for this one, which what city I'm going to travel, it based on the vectors. It's the search and then gets you right 86 tokens, 1.23 seconds. So this is on the retrieval memory. The same happens on the summarization. It summarizes it has some buffer. Same happens with sliding window memory. You have memory augmented memory, and all of these classes are defined here. If you go to memory augmented, you can see it says it's a combination of sliding window with persistence memory tokens. Okay, there are advantages and disadvantages for this also. It's a complex implementations, additional LLMs calls increased cost, and so on and so forth. So we have memory augmented memory, we have OS memory, which is again RAM like thing. Retrieval we talked, sequential we talked, sliding window we talked, pretty standard. Summarization memory, it's pretty standard also. It compresses conversation history using LLM, like it summarizes your conversations and then based on that it decides it when you ask questions. And then we have graph memory based on network X for relationship modeling. What you can also do, you can also do batch comparison. So let's say here the question, my name is Alex, blah blah blah. You can see I'm a software engineer, I'm working on a machine learning project, I prefer Python and love coffee, what do you remember about me? And you can see you can run batch test, you can select multiple memories combinations, and you can compare with each other. You can select from the drop down. Basically from the drop down you can select it and it can work. So you can see it over here. Look at the average tokens, right? For retrieval memory 74, and for sequential memory 104. These are all trade-offs, by the way. Okay, it's something that you have to see, like it's a trade-off. If you look at the final response, I remember that your name is Alex and you are a software engineer currently working on a machine learning project, which is correct. You prefer using Python and love coffee. If there's anything else you would like to say, look at the memory statistics, right? Total turns 4. It took 4 turn. Of course, token costs have been a bit higher than that we see the average tokens. I'm talking about the average tokens, guys, not the complete tokens. Complete tokens can be found here in this total one. Now that is the one. In the retrieval is a bit difficult to work, right? See, people always say that why can't we build 100% successful RAG systems? Problem is not with LLM. Problem is, I will also not say, is like with, you know, problems are with the retrieval part, guys. Retrieval is one of the most complex, very intuitive. A lot of people do, people who works in that area where they do research. The problem is in the distance based algorithms. That's where the retrieval algorithms are difficult, and that's why we don't get 100% correct results. If you look at here, it says, hi Alex. I remember that you are a software engineer. You mentioned wanting to discuss the projects you are currently working on, the technologies, blah blah blah, right? It was not comprehensive as this because it also captures Python and love coffee, but this also captures that software engineer Alex, blah 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 blah, right? So it also works that way. So on this playground that you see, you can also use different memory design or optimization strategies to kind of compare with each other. We also have a performance dashboard that you see. On the performance dashboard, you can find out token uses comparison, you can find out response time analysis, so on and so forth, right? With the current model that we have used. This has been used through Plotly Express. We are using Plotly to do that. Now let's go back to batch comparisons. You can see all the sessions are there. So we're using Streamlit sessions to make sure that the responses are there, even if you change the tab, right? And this is the overview. You can go through other memories also, guys. I don't want to create a very lengthy video. Here you can read about in detail and can understand that how other memories are also working, because this will help you make sure that you get the fundamentals cover understanding of the memory management, and then you can build a better agentic system on the memory part. Go through the code. Everything is modular. You see graph memory, compression memory, everything is modular, so you can use it in your example uses. You can use this in your file. You can see I've written each strategies can be easily swapped and tested. It's a plug and play module that we have used, and you can test it out yourself, not a problem. Now, going back, right, why these are important, and I have created this agentic AI toolkit. In that toolkit, you can get governance toolkit, you will get 100 plus N10 workflows, success frameworks, you will get use cases kit and skill builder. All of these you get in a single agentic AI bundle kit. And if you want to go details about what this kit contains, you can see we have in the agentic AI governance, because governance is really important. And this is not for individual. If you are some individual, who is just trying learning AI agents, this bundle is not for you. But it also has a 3 months skill builder kit. So it also has learning roadmaps. So it has learning roadmaps where we talk about phase-wise weekly breakdown, it hands-on projects, deployment tools, portfolio builder, your job preparation templates, your bonuses in that 3 month skill kit. Then we have use cases selection kit. Not all the use cases requires AI agents or agentic AI guys. Discriminative models are also very helpful in today's world. You can still use machine learning, natural language, or deep learning based models or algorithms. You don't need everything to be done by AI agents. So these use case selection kit, helps you, navigate those challenges or confusions on what to do, when to do, kind of a scenario. And then we have success framework. In the success framework, we have full life cycle template to manage your AI agent projects, architecture diagrams, memory optimization that we just saw. It's also part of that kit. We have evaluation strategy, anti-failures checklist. We have multiple models, pitfalls, build versus buy metrics, when to build, when to buy, kind of a thing. If you are a startup founder, or if you are somebody who is starting a new AI department or initiatives, this can really help you. We have N10 workflow templates, battle tested templates, guys, all tested, if you want to use it. And then governance and risk management toolkit. All these five comes together in a single kit that I have named it Agentic AI Toolkit. I'll give the link in description. Check it out. If you're interested, take it. If you're not interested, that is completely fine, up to you, right? It's pretty affordable prices. It took me more than 4 months to design and compile and curate this. So you can find it out over here. And lifetime updates. Every week I make updates. I keep pushing, more collaterals and projects and private repositories into this kit. So you can find those in description, right? Going back to the memory design and optimization playground, very, very important, guys. Focus on memory. Look at this open source project. I'll give the link in description on my GitHub. Check it out. I'll also deploy this so you can try it out by yourself. And if you want to contribute to this repository, make a pull request and we'll see from there, right? And if you have any question, thoughts, or feedbacks, let me know in the comment box. You can also reach out to me through my social media channel, guys. Found this information on channel banner and channel about us. If you like this video, please hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel, guys. That motivates me to create more such videos in near future. That's all for this video. Thank you so much for watching. See you in the next one.